Hello all, welcome to the subject of VLSI Design and Technology. This is Professor Meenakshi Panchal from Electronics and Telecommunication Department, Parvatibai, Canva, Mochi College of Engineering, Wagoli, Pune. In previous lecture, we have discussed about data types coming in the VHDL programming language. So in today's lecture, we will see the different types of the VHDL and what are the types of the description, how the model will be described here. There are different styles of writing the description. The styles adopted in the block can be classified as a behavioral, structural, switch level, data flow, mixed style or mixed type or mixed language. This section, the following section will be briefly discuss these styles one by one. First, let's see behavioral style. The behavioral description. A behavioral description model of the system as how the output behave with the input. See here how the output behave with the input. This descriptional model system as how the output behave with the input. The definition of behavioral description is one where the architectural or the model include the predefined word process VHDL. The description is considered pure behavioral if it does not contain any other features from other styles or other descriptions. The pure behavioral description, according to the definition, we will see the example here one by writing the architectural of VHDL in a behavioral description. Let's see one of the examples is half adder. Here the half adder, we are going to write the architecture in a behavioral description of this half adder. This is the library and we are going to write here description. After library, we are going to assign entity. So entity is going to assign by using a predefined word entity. And after the file name, we are going to write the description of half adder. So I am going to write the name half adder. Half add is. After that, I am going to assigning a port. What are the inputs and outputs in half adder? Here A. Here A and B. Here A and B are the in bits, input terminals, and which is in bit form. And sum, I'm going to write yes only here, sum and carry. There are two output terminals are there, and I am going to write like out, which is also in the form of bit. After declaring port, I'm going to end the entity by using command end, which is also predefined with the name of add. So always architecture will be begin with the predefined word begin begin. Next, we have to write process A, comma B. We have to process on these two terminal. These two are input terminal, which are A and B. Here, the above statement is process statements. Now let's begin how the output behave with the input. This is the main important task of structural description. We have to mention how how the output behave with the input. Here my output sum, which will behave or which will perform XOR operations. So here A, which perform XOR operation. How we are going to assign a XOR operation we have discussed in logical operator lecture. So XOR operation will be write the code by using XOR. This is the code we are going to write XOR B. A XOR B after 10 nanosecond. Here I am declaring the time also after 10 nanosecond. The sum should be performed. The sum should be obtained. What sum which should be obtained? The logical XOR operations of A and B. This is the sum. And next C carry. How the carry will be behave and how carry will be obtained by the input behavior, that is A and B. Here AND operation will be undergoes here A and B. So AND operation will be undergoes here. Hence carry will be obtained. Carry will be obtained A and B. This is also after 10 nanosecond. After we have to end with a predefined word and process. And after that we have to end the behave. Here one thing is there, before begin assigning operator in a behavioral model, we have to mention here which architecture we are going to use. We are going to use behavioral architecture now. So we have assigned here architecture behavioral we are going to use. I am writing here short form. We have this example of behavioral style of half adder. Which example we have taken? Half adder is. What is the above statement states that the above statement, the above architecture consist of a process construct. Then we will begin with the begin statement. Here These are the entity. After library, we have to start with the entity. We are going to assigning entity, which is what are the input and output ports by predefined word entity and the name of the architecture. Here we are going to writing the behavioral description for half adder. So I am writing here name as half underscore add is also predefined word here. Then I'm going to assigning port. Here there are two input terminals A and B, which is mentioned by using in, and those are bit types. Bit type data will be operate or perform the bit type on the bit type data. The operation will be performed here. And yes and C. Yes is means sum and carry. These are the output terminal I have mentioned by using out, and these also bit type. So entity will be end by using predefined word end and the name of the entity half add. Half add and semicolon is nothing but end the entity here. Then we are going to write the architecture here. What architecture we are going here? Behavioral architecture. So I am going to write the name in a short form behave underscore x of this half adder. These entities for this entity, I am going to write the architecture here. Half add is here underscore the above architecture consists of process construct. Here we have to begin with the process. After begin statement, we have to process on A and B. Here the two input terminal on that all the things should be processed. Here process A and B, there are two input terminal, and after that we have to begin how the output will be obtained on the behavior of input. This is the main thing of behavioral description. Here we have to just describe that how output will be kept. The sum will be get by XOR operation of two input terminals. So here A and B are two input terminals. Here we are performing XOR operation. After each 10 nanosecond, here time will be given. After 10 nanosecond, each some result will be get, and which is in sum. And carry, we are same here. Similarly, the carry operation will be obtained by the carry operation result. The carry will be obtained by the AND operation of these two terminals A and B. At the data AND option will be obtained and carry will be obtained here. So after writing after assigning all the outputs, our process should be AND with the AND process. And after that we have begin here. There are two begin is there, so each begin there should be and should be right here. So here process will be end at from this statement to this. Here we are going to end for this begin. So we are writing end and what this architecture we have X. This is the one of the example of behavioral type of architecture. Let's see the structural description. The structural description here. Structural descriptions model the system as component or a gates. These descriptions is identified by the presence of keyword complement in the architecture. Here the gates construct such like a and or not, such type of construct we have to consider. If the VHDL architecture how the architecture will be assigned in the structural description, we will see by using the same example. we have considered here half adder. So this is the library. See how the architecture will be constructed by using this structural description. I am going to write here same entity of system is. Here I have considered the name system is, and I am going to assigning 4, that is A comma B in bit and some count or sum or C out. Sorry, this is C out. C out is nothing but carry out. Here I am taking AB as these two input AB and sum and carry is the output. And these are the output terminals and which is in the form of bit. After declaring the entity, I have to end with the end command, the name of entity, that is system. After that, I have to mention here architecture. Architecture which is in a structural. I'm writing here short form struct. Example of the entity name system is. Here is a predefined word. Here I am using component. That what are the component we are going to use. Here I am going to use the XOR gate and AND gate. These two components we are going to use in our half adder. So I am going to assign the first component is XOR. So component XOR XOR. I am giving two. There are two components. And the above statement is a component statement. Here this statement mentioned that the above statement is a component statement. I am going to assigning port of that particular component. Here we have to mention the description about each component. We are going to use two AND gates are there. So we have to give the information about each gates. The first component or first gate is XOR 2. I have given the name like this, XOR 2. And in this type, there are two input terminal. So the input terminal name here, this and this should be different. Here two input terminal I have given in the XOR gate. There are I1 and I2 two input terminals and 0 1 is one output terminal. Here some except in the name of sum I have given here 0 1 is the output. So this is the first component description. And after describing the component first, I have to end with the end component. This statement I have to end. Then I have to provide the component to information, that is, and to I have given the second component name here, and the port information I have to give similarly that I have mentioned in first component, that is component 2, which is having same input terminal I1 and I2 in bit, and one output, that is 0, 0, 2 out bit. These are the information about two components, and the second component information I have to end with the end statement and component. In the structural type, we have to first give the information about the each component and what are the inputs and output. All things we have to mention first. Then we have to begin with the begin command. Here the output x1 I have mentioned here, and which performs the first component operation x or 2, which should take port information by using map command. I am going to write a comma b comma sum. This is the style of writing the architecture of structural. Based on the structure, we have to mention here the first entity. We have mentioned the two input terminal like I name AB, and two output terminal sum and carry. So we have to map these component by giving A, B and sum. The XOR operation, it should using that port information, using this port information, which will map the terminal information. And second output I am mentioned at A1, and which it should use component 2 port and map A comma B count. Then we have to end with the structure name. Here we have begin with a structure name. This is a architecture structure. We have to end with this name. Control C and Control V. This is the example of structural architecture. This is the example of structural operation. Here the information about each gate or component we have to define first, and then we have mapped our input and output terminal with those component port information. Now let's see switch level description. The switch level description is the lowest level of the description. The system is described by using switches or transistors. The VHDL does not have any built-in switch level primitive, but we can construct the packages to include such primitive and attach primitives and attach them to VHDL model. So let's see one example of switch level description. We are going through same example of half adder. Here how the architecture will be described in a switch level. Let's see. Because of this switch level, this mainly describes the using switches of the transistor. So we are going to construct a switch level description by using example of inverter. Here, here the figure shows in a slide which is a inverter which is having single input and single output. The inverter, if high input is provided to inverter, which will provide a low output, and if it takes zero input or low input, which will give a high input. This is the inverter which is using two transistors. One is PMOS and another one is a NMOS. Using this transistor, we are going to write the switch level description. So let's see how to write. After declaring library, we have begin with the entity and the name of entity is in water is and assign a port of the inverter. There are a one input that is one output that is Y, and output is assigned by using out, and which is a standard logic type. Standard underscore logic data type. What is the meaning of standard logic data type? I have explained in a data type lecture. Standard logic. And A is the input which is mentioned by using int std underscore logic. And I'm going to end with the name of the entity in water. So this is done with the entity. Now we have to mention which type of architecture is architecture inverter switch type. Switch of inverter is. This is the name of the entity here. Inverter I have mentioned. This is the architecture name I have taken as inverter switch. So what components we are going to use in switch type? We are going to transistor types components. That is, first we have considered NMOS component. Component NMOS. Here NMOS is one of the key word inverter is. Component NMOS. Sorry. Here NMOS is the one of the here NMOS is one of the keyword of the inverter. How we are going to assign by using port? I am going to write there is a one output terminal in which is in a form of std logic form data logic data I1 comma I2 in std logic. And component. Now discuss about next component by using predefined word component PMOS. There are two components are there. One is NMOS and another one is PMOS here. So PMOS. Here the PMOS is one of the keyword for switch level. This is one of the keyword, just a keyword. And now we are going to assigning the port 01 here out std underscore logic I1 comma I2 in std underscore logic. And we have to end the component information with the end predefined word and component. Here we have mentioned the information about two components. One is NMOS, another one is PMOS. Now we have to write for all PMOS use entity work dot MOS for all NMOS use entity work the above two statement are referring to a package MOS see the details in let. So let's begin. Constraint. The other constraint we are going to provide here, like a VDD and PSS. So first, we are going to constants. One is VDD and which is in a form of std underscore logic form. That means high. We are assigning VDD is nothing but high. And second constant is there. That is, we can assign it VSS or ground. That is in the form of std underscore logic, which means we are going to assign the 0. Now begin P1 is nothing but PMOS. Here PMOS. Here this PMOS is going to refer here. First PMOS here. PMOS which port map takes place Y, comma, VDD, comma, EA here. The Y input with respect to VDD, Y is the output, VDD constant, and A is the input. Here the PMOS transistor operation will be takes place. Similarly, here N1, NMOS, so NMOS port map should be takes place with similarly Y is the output and G and D ground, 8. Then end inverter switch. Here, this architecture inverter switch is going to end here. Here, see, in the last description, structural description, we have referred the component which gates we are going to use. So that kind of description we have seen. But here in switch level description, we are going to refer the transistors. We have to provide all the details about the transistor we are going to use in our design circuitry. So this is our inverter operation. Here, two transistor we are going to use, NMOS and PMOS. Here in the switch level description, we are going to give all the description about the components used in transistor components are used in the our application. Here this is the inverter function. Here the two MOS transistor will be used. One is NMOS and another one is a PMOS. So we have to begin with the, after declaring library, we have to begin with an entity. After entity is a predefined word. Here the name of application is an inverter, and we have to declare the port. Here one output terminal is a Y and one input terminal is A, and these are in a form of std logic data type, and we have to end with the end predefined word and inverter. Then we have to start architecture, and we have to write the architecture name inverter switch of the inverter. Here inverter is the name of the entity. For this entity we are going to writing the architecture. So we have to mention the details about each component one by one. First, we have to begin with the predefined word component and MOS. Here the component NMOS, which is having port, one output, and two input logics. Here we are going to give a two input signals. One is A input and another one is either VDD or VCC. On what the data will be the transistor will be operate. And the next component is PMOS. Similarly, the port architecture of PMOS will be declared here. Here one output will be declared as a 0, 1, which is out. This is also STD logic data type, and I1, I2. There are two input terminals and two input signals are going to feed to this transistor. So for all the PMOS use entity work, and MOS and all the NMOS use the entity work. And what are the entity we are providing here, which will use the behavioral of each transistor. The above two statement referring the packages. These are the packages will be going to refer. .mos packages will be going to refer. Then we have to provide two constant. One is VDD and then another one is ground. VDD, which is in the form of STD logic data type. That means high signal will be going to feed as the name of VDD. Then similarly ground, the low signal will be going to feed as the name of ground. After declaring these two constants, we have to begin with our architecture. We have one transistor P1, PMOS output. The output is the PMOS of output transistor we have named as a P1, which map the port which map the port of all the PMOS component. This PMOS component operation port will be going to map here, and which having Y, which provide as a Y output VDD constant, and A is the input here, which will declared in the entity. Similarly, the NMOS port uh, components we are assigned here, we are declared here, that will going to map